The central limit is valid as long as we are taking many, many small random samples, and then they end up being evenly distributed over our whole distribution and end up giving us a normal distribution. This is exciting because it helps explain why so many variables we come across end up being normally distributed. So as we look through this one here, we're wondering if our number of 14.7 is a parameter or a statistic. In this case, it's a parameter because you're referring to all Ford cars. When you're looking for at least one, you're not actually representing it by a number, so we know it cannot be mu or x bar. It's a category, and in this case, since you're dealing with all Americans, it is P. If you're dealing with a sample of your Americans, then it would be P hat. Remember, if it's a number describing your population, it's mu. If it's from your sample, then it's an x bar. This one here is x bar because it's a sample that we are looking at, and it's a mean, which is a number. This one here, we would want to take a larger sample because the law of large numbers says the larger a sample or the more times we repeat our measurements, we get a more accurate observation. The law of large numbers pretty much says that if we increase our sample size, then x bar will become a better estimate of mu. As we look here, we want to know if we end up doing a sampling distribution based on this being our population, what would our sampling distribution look like? Well, remember your sampling distribution is going to be not nearly as wide, and it's going to end up looking normal. So this one here and this one here look reasonably normal. This one here is just a repeat of your population, so we know it's not C. The only difference between these two here is this one's got about the same standard deviation, or how far it's spread out, as your population. This one here is a much smaller, which we would expect it to be since we're dealing with the sample size being 50. So then you would expect it to be spread out 1 over the square root of 50 as much, which is about 1/7 as wide, and this is about 1/7 as wide as this up here. Now, which of the following are true here? Well, in this case, the shape of your sampling distribution gets to be approximately normal as n increases. Now, for small values of n, it may not be normal, but as n continues to get larger, your sampling distribution becomes more and more normal. This one here is true because remember your sampling distribution is always being divided by the square root of n for your standard deviation. This one here we would say is false. And our sigma over the square root of n tells us our standard deviation from our sampling distribution, which is always from our x bars. So it's how spread out our x bars are. So in this one here, we know we have a mean of 5, standard deviation of 5. But if we take a sampling distribution, remember our sampling distribution would still end up having the same mean of 5. Even though it's extremely skewed here, when you do a sample size of 100, it's going to then end up being approximately normal. The question then is it going to be approximately normal with a center at 5 and a standard deviation of 5, or at 0.5? Well, remember your standard deviation is sigma, which is 5, over the square root of n. So it would be 5 over the square root of 100. Square root of 100 is 10, so it would be 5 over 10, which is your 0.5. So we get D. So, what effect does increasing your sample size have on the center of your distribution? Well, in reality, it has no effect. It's only when you increase your sample size that it affects your standard deviation of your sampling distribution. And so that's what we're dealing with down here. So when you increase your sample size, your spread, your standard deviation, ends up decreasing or getting smaller. So what effect does n have on the shape of your sampling distribution? Well, your sampling distribution begins to look more bell-shaped, more normal shape as n increases. Now, if you want to spread or decrease how spread out it is, you then need to choose larger sample sizes. Here we know the mean of our population, standard deviation of the population. We know it's the mean of the population because it's mu. We know it's the standard deviation of your population because it's sigma. If we go ahead and do a sample size of 24, what will be the distribution of our x-bars or our sampling distribution? Well, it's going to have the same mean, so we know it's going to be one of these two. And when we're looking at a sampling distribution, size of 24, we know it's going to be approximately normal, so it's still going to be one of these two. The only difference is the standard deviation from our sampling distribution. And remember, our sampling distribution always has a standard deviation of sigma, which is 6, over the square root of n, which is 24. So it would be 6 over 24, square root of 24. So we get B.